here's how it goes. If we're given a 2x2 matrix, we label the entries A, B, C, and D. And then what you want to do is you want to calculate this value, AD minus BC. Take a look at this fraction that you have here, and take a wild guess at the number that we do not want AD minus BC to be equal to. That's right, this trick is only going to work if AD minus BC is not equal to 0. If that's true, then what you do is you can take the values of A and D, switch them, take the values of B and C, change the sign, and then multiply by the fraction AD minus BC. If you do end up getting the value AD minus BC equal to 0, then you can automatically conclude that A inverse does not exist. So let's go ahead and do some calculations using this shortcut formula for these two 2x2 matrices. So for matrix A, we have that A is 2, B is minus 1, C is 1, D is 1. And we can calculate AD minus BC. That's going to be 2 minus negative 1, or 3. So A is going to have an inverse, and A inverse looks like this. 1 over AD minus BC. We switch the order of the numbers on the main diagonal, and then we change the sign of the two remaining entries. And then finally we multiply through by the fraction 1 over 3. So there's our inverse for matrix A. For matrix B, we have A is 2, B is 2, C is 1, D is 1. And that gives us AD minus BC is 2 minus 2 for 0. This tells us that B inverse does not exist. The nice thing about the 2x2 formula is I can at least motivate why it has to work. So what we can do is we can take our matrix A, and we can take our matrix A inverse. All I've done over here is I've taken this fraction and I've multiplied it through to each of the entries inside of A inverse. And if we were to calculate the product of A and A inverse, we could write it as the following. And then we use matrix multiplication to distribute our numbers through. I've done a little bit of simplification, but these are the values that we get when we distribute the rows to the columns. And you'll notice that along the main diagonal, we get AD minus BC divided by AD minus BC. So on the main diagonal, we just get 1s. Off the main diagonal, in the numerators, we're either going to get AB minus AB or CD minus CD. So off the main diagonal, we're going to get zeros. So what we've shown is that A times A inverse is equal to a 2x2 identity matrix. And I'll leave it to you to show that when we go A inverse times A, we also get a 2x2 identity matrix. And this is why the 2x2 formula works. And while we're on the subject of inverses, it's worthwhile to go back and revisit matrix powers, because now we can extend the idea to negative integer exponents as well. So for example, a to the minus 2 we could say is A inverse times A inverse. A to the minus 3 would be A inverse times A inverse times A inverse, and so on until we get to A to the minus k, which we could define as A inverse times A inverse k times. Alright, my little epsilons, stay positive.